Welcome to massive open online course on basic principles and calculations in chemical engineering. So, we are discussing this introduction on this basic principles and chemical calculations in chemical engineering under module 1. Now, in this module we will discuss today about the unit systems and dimensions. As we know that we are using different products in our daily life, like that may be some grocery products, even some transported products, even some other pharmaceutical products. So, all those products of course are produced based on certain principle of process. Now, that process depends on different that variables, different input, even different output also, whatever it is coming after processing. So, to quantify all those process input and output, it is required to represent that quantity by a certain unit or that dimensions. So, that unit systems and dimensions it is required to know for the analysis of their process efficiency based on certain mathematical expression. Now, to express all those process efficiency by that mathematical expression, you have to assess all those mathematical expressions by equation, whether those equations are dimensionally homogeneous or not, or how to analyze those variables based on the dimensionless quantity to scale up those process to industrial scale. So, that is why we are going to discuss here what are the different units and dimensions are actually used for that analysis of process variables and their input and output, and also for the analysis of that model equations based on the dimensional analysis. So, in this case we will discuss all those variables. Now, before going to that, you have to know what is the definition of that unit or dimensions. Now, the unit actually indicates the what measured quantity actually represents. Now, a measured or counted quantity has a numerical value and a unit. That measurable units are specific values of dimensions that have been defined by convention, like for mass you have to quantify based on the units like grams or kg or pound, like this. For time you have to express it by unit like seconds, and for the dimensions, like for the length, that you have to express it by certain units like centimeter, meter, even foot, even inches, all these things. And you will see that dimensions also is one of the important measurable quantity that the unit represents. Example like length, mass, time and temperature, all are represented as a dimension. Now, it also be calculated multiplying or dividing other dimensions there. So, whenever you are going to represent any unit by dimensions, that dimensions may be multiple of 2 dimensions or dividing of 2 dimensions, or that combination of dimensions in such way that there will be a certain form of that unit there. Like if you are representing the velocity, then you have to make its unit like what should be the length and what should be the time, because this velocity is defined by length upon time. So, in that case what is the dimensions of that velocity? It will be that L by T. What is that? L is actually dimension of length, and dimension of time is T. So, it will be that length per time. And similarly, volume, what should be the dimension of that volume? It will be actually length cube volume of that, so it will be actually L cube. and similarly density, this is basically the defined by mass per unit volume. So, in that case what should be the dimension of that density? It will be like kg per meter cube, like that. So, in this way we actually represent any process quantity or variables quantity by certain unit or by certain dimensions there. So, anyway chemical engineers like many other engineers, they also use the values, units and dimensions all the time for the analysis of process efficiency based on certain that models or mathematical expression. And what are the that you will see that there are different systems of units are available to represent those mathematical expressions or quantity of the variables which are being used for process analysis. So, there are several systems of units, but two primary systems that engineers generally use, those are like International System of Units, that is SI system, and the American Engineering System of Units, it is actually in short form it is called AES. Other systems also available like centimeter gram second, that is CGS system, and foot pound second system, that is FPS system, and the British system of units like British here. And in this case of course all those systems are conventionally being used by engineers for analysis of process. And next you will see that what are the units that associated to the systems. In this slides in a table it is shown that at different systems the units of mass, length, time and temperatures are given here. So, please go through this the units of those mass, length and time, temperature based on different systems. Here in SI system generally internationally that uniformly used their systems for any process analysis. In that case what is the unit for mass? Generally it is represented by kilograms, and length it is represented by meter, and the units for time always it will be time second, and also the temperature it will be in terms of kelvins. So, SI systems are following like this, whereas if you are considering that AES degree systems, there you will see that pound mass it will be represented as a unit for mass, whereas foot will be a unit for length, and second the same way as SI it will be second for time, and temperature it will be Fahrenheit. Whereas in CGS and FPS systems respective that units are given here in the table for mass, length, time and temperature respectively. For British systems earlier they have used that slug system, foot, second and degree Celsius for mass, length, time and temperature. So, this for internationally for uniform system they are using they are actually using and that system always to be maintained as SI system, so that it will be analysis through analysis that process uniformly all over world. And but whenever you are going to express that process variables quantity by other system, then you have to convert it to one system to another system by certain factor. That factor of course will be that if you are considering other new system based on old system, then you have to multiply by a factor of new unit by old unit. So, to convert a quantity expressed in terms of one unit to its equivalent in terms of another unit, you will need to multiply the given quantity by the conversion factor. So, by that conversion factor you can easily calculate what should be the unit for any variables quantity. And then to express all those process efficiency, you sometimes need to express mathematically those process efficiency by equation. Now, whenever you are going to express those equation, you have to verify whether those equations are dimensionally consistent or not. So, it is called homogeneousness of the dimensions of equation. So, you have to identify, you have to calculate of the units or dimensions of both sides of the equation, whether the dimensions are same or not. That will be actually uniform in dimensions on both sides to express that process efficiency by mathematics. We can say that some units will not have dimensions, though it will be called as exceptions of units, like coefficients in physical laws that do not have units. Example, suppose kinetic energy it will be half into m into u square. So, in that case you will see that the coefficient half will not have any unit here. Similarly, exponents also will be unitless, like if you are expressing that u square or b square or that certain other variables that to the power some value, then that power or exponent will be that unitless. Similarly, arguments are unitless, like x is angle that may have some unit degree, but sin x that will not have any unit there. Similarly, cos x, tan x or tan theta, cos theta will not have any unit. So, arguments are unitless. Similarly, some quantities, some expressions that are very important to express the process process type, or you can say that whether that process is highly turbulent, or you can say that laminar. Like if any liquid is flowing through the pipe, you will see that the velocity of the fluid will be in such way that liquid will not be moving very that laminar way, or you can say that without disturbing of this molecule, it will be that flowing through the pipe. So, if the molecules of the liquid is moving without actually displacing on its path, across its path, then you can say that the flow will be laminar. Whereas, when this fluid molecules will be moving in such way that all the molecules will be randomly moving throughout the pipe. So, it will be called as turbulent. Now, this laminar and turbulent flow, how will you assess quantitatively? So, in that case you have to find out some dimensionless number, that is called Reynolds number. So, here Reynolds, Osborne Reynolds, he did experiment to find out the criteria of getting the flow of laminar or turbulent based on this Reynolds number. Why it is called Reynolds number? And this is number because here the dimension of this quantity will not have any dimensions here of this quantity. So, it will be a number, because here you will see that if it is defined by this rho u d by mu, where rho is the density, its unit is kg per meter cube, or you can say its dimensions is meter per L cube, and u is the velocity, that is meter per second, and d is the unit here, and viscosity is nothing but kg per meter second. So, if you substitute all the units here for this variables rho u d by mu, then you will see that the dimensions will be nullified. So, in that case it will be converted as a number. So, that is why this number will be regarded as Reynolds number. Now, if Reynolds number is less than 2300, you can say that the flow will be laminar, whereas if it is greater than 4000, it will be highly turbulent. So, by this analysis of this dimensionless number, you can assess the process how it will be there. So, these dimensionless groups, there are so many other dimensionless groups like this, you will see in chemical engineering process calculations there, and all those dimensionless groups will be having no dimensions there. So, this is called dimensionless number. So, these are called exceptions of units there. So, all are different kinds of exceptions of units that I have shown, some coefficients in physical laws, even exponents are unitless or dimensionless, arguments are unitless, dimensionless numbers are dimensionless. So, like this or unitless you can say. So, this. So, you have to remember that what type of laws are dimensionless or that will have some dimensions. So, in that case, based on which you have to make the equations of course, dimensionless on both sides. Now, let us have an example like this here, make the equation dimensionally consistent. How to do this? Like if you suppose that a composition C which will be varying with respect to time in a process. Now, that concentration variation with respect to time, if you express by this equation y is equal to a into e to the power minus b x, where y is concentration whose units is kg per liter, whereas this x is actually denoting for that time. So, in that case its units will be seconds. Now, as we know that this that exponents that will not have any dimensions. So, if you are following that law here, so this b, the dimensions of this b will be having in such a way that this exponents that is this exponents will not have any dimensions. So, how to do that? So, b dimensions of this b will be in such a way that it should be nullified after multiplying of b and t. So, what to do? You know that dimension of time is second. So, the dimensions of b should be 1 by second. So, that second into 1 by second it will be nullified, it will be converted into 1. So, in that way it should be that dimensionless. So, this part should be dimensionless, but your left hand side will have the dimensions of kg per liter. So, you have to make the consistent of this equation in such a way that the dimensions of that a should be kg per liter. So, in that way it should be considered or made the consistent of the dimensions. So, what are the units associated with a and b to make this equation dimensionally homogeneous or consistent? You have to make the unit of a as the same as the unit of y, that is kg per liter, and also you know that exponential function must have dimensionless. So, the figure b must have a unit that is 1 by second or second inverse. So, in this way you have to make the equation dimensionless on its both sides. Like another example, you can say consider the equation s is equal to 70 plus 8 t square, where s is referred as distance, so whose unit is meter, and time is represented by t and its unit is second. So, what are the dimensions of 7 and 8 here? So, you can represent that, you have to just make it equivalent dimensions on both sides of this equation. What is the unit for s, what is the unit for t, what is the unit for t square. So, accordingly the other coefficients will have the dimensions to make it consistent for its dimension. So, in that case unit of 7 will be meter per second and the unit for number 8 should be meter per second square. Similarly, dimensions will be that m by L and also m by you can say S, and also dimensions of that 8 will be m by S square. The thermal conductivity of K of a liquid metal is like predicted via the empirical equation, like K is equal to A into exponent of B T, where K is in joule per second meter Kelvin and A and B are constants. So, T is absolute temperature. So, what should be the dimensions or units of A or B? So, in this case similarly, to make it dimensionally homogeneous or consistent, you have to make the unit of A same as that that K. So, it will be joule per second per meter K. Similarly, B has the unit of T that is K. Now, you can try yourself this problem yourself to make this dimensionally consistent. Now, another important aspect of dimensions for the chemical engineering process, like whenever you are doing any experiment and getting some results of the process efficiency. Now, to make this process viable to industrial scale, you have to express that mathematical expression or model to make it industrially scalable. Then what you have to do, you have to do the dimension analysis of the equations from its lower scale to the upper scale there. So, in that case in laboratory scale, sometimes you cannot actually you cannot do that experiments possible to carry out on its full size of units. So, there the experiments are carried out in the small scale. So, in that case to make it that industrial scale, you have to make some model based on that experimental data. Now, once you make the model equation universal model equation or empirical model equation based on your experimental data, you can predict those that process output quantity based on this model and that based on the process variables and you can predict at larger scales just by changing the value of that process variable quantity. So, whenever you are making that equation to be used to calculate for the higher values of process variables, then you can get the higher values of or projected values of what is that process output. Now, based on that industrial scale process equipment to be developed based on this experimental data and its model development. So, in this way, whenever you are making any model equation, you have to make it dimensionally consistent, and to make that dimensionally consistent, you have to that make this as dimensionless form, and that equations to be sometimes to be converted into a dimensionless groups or dimensionless number. Now, to make those dimensionless number, you have to do some dimensional analysis. There will be a certain way to do that. So, that process we will discuss here. There are that two process to do the dimension analysis based on the process variables. If there are n number of variables for analysis of that process, then you have to make all those process variables in a dimensionless forms in such way that on the left hand side and right hand side of the equations will be dimensionless. So, to make that, there are two process. One is called Rayleigh method, another is called Buckingham pi theorem. Now, to analyze by these two methods the equations dimensionally consistent or dimensionless number based equation, you have to know some primary fundamental units based on which those dimension analysis to be done. Now, that primary fundamental units are that length, mass and time. Based on these fundamental units, you can do the dimension analysis to make that dimensionless groups. Now, we will do that here one by one, and before going to that you have to know some important dimensions and also you have to remember here in this slides it is given some that variables like geometrical variables, kinematic variables, dynamic variables, even fluid properties as a variables, and their quantities like geometry like area, volume, even moment of area, even you can say that kinematics like velocity, acceleration, angle, angular velocity, quantity of flow, mass flow rate, even dynamic variables like force, moment, torque, energy, work, heat, power, pressure, stress, all those things, even some fluid properties, density, viscosity, surface tension, kinematic viscosity, thermal conductivity, specific heat, even bulk modulus of the fluid like that. So, all those quantity to be represented by certain dimensions. Here in the slides also these dimensions are given respectively. Here all those dimensions will be required to analyze that dimensions and to make it dimensionless group. So, for that this I told that two methods are there, one is Rayleigh's methods, another is Buckingham's pi method. So, you have to remember these two methods, and both the methods of dimension analysis determine only the relevant independent dimensionless parameters of a problem, but not the exact relationship between them. So, here we will make it, let us discuss about that Rayleigh method first. The method involves the following steps here. Step 1, here note all the independent variables that are likely to influence the dependent variables. Like any process, that suppose there is a flow of fluid through the pipe. Okay. Now, you will see there will be a change of pressure whenever fluid will be flowing through the pipe. Now, pressure is one dependent variables, based on some other independent variables it will be changing. How? Like pressure will be changing based on the, if you change the diameter of the pipe, pressure will change if you change the velocity of the liquid, pressure will change if you change the type of the fluid, that is its physical properties. So, based on which you will see that there will be a change of pressure drop. So, that is why here dependent variables is pressure drop, whereas independent variables are that surface physical properties of the system, diameter of the column, length of the column, even that what is that velocity of the fluid, even is there any roughness of the fluid or pipe or not, that also will give you that change of pressure drop like this. So, you have to note all the independent variables that are likely to influence the process, and also dependent variables on which these independent variables will be affecting. Then what you have to do, if y is a variable that depends upon independent variables like x1, x2, x3 and xn, then write the functional equation as y will be equal to what is that function of x1, x2, x3 dot 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 xn. There may be n number of variables will be there. It may be 2, 3, 4, 5, 6, 7, 8 more number of variables will be there, that will be independent, whereas dependent variables will be certain variable there. Okay. So, in this way you have to express the functionality of dependent variables based on that independent variables. After that, what you have to do, write the functional equation in the form of like this, y is equal to like c to x1 to the power a, x2 to the power b, x3 to the power c and dot 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 xn to the power m. So, in this case you are actually making this certain relationship of those independent and dependent variables like this. Here c is the constant, here dimensionless constant, and a, b, c and m are arbitrary exponents. Those exponents c, a, b, c, all those exponents will be obtained from the experimental data based on your process. And then after that, express each of the quantities in the equation in fundamental dimensions in which the solution is required. Now, after that, by using dimensional homogeneity, obtain a set of simultaneous equations, that is involving the exponents a, b, c and m. After that, you have to solve these equations to obtain the value of exponents a, b, c and m. Then form the dimensionless groups by the variables with like exponents. We will do that example of this methods, like here let us consider a frictional resistance that is represented by F. When a liquid is flowing through a pipe, that depends on viscosity, density of the fluid, velocity of the flow, diameter of the pipe and the pipe roughness. Now, you have to derive a rational equation for the pipe flow in terms of dimensionless groups by Rayleigh's method. What you have to do? Same way that step 1, step 2, step 3 you have to follow like this. As a step 1, you have to first identify what are the dependent variables and independent variables. What is that dependent variables? That is frictional resistance, because this frictional resistance, depending on that, you know that viscosity of the fluid, density of the fluid, velocity of the fluid, diameter of the pipe and also roughness of the pipe surface. So, this viscosity of the pipe is denoted by mu, density of the viscosity of the fluid is denoted by mu, density is denoted by rho, velocity of the flow is V, pipe diameter d and pipe roughness as epsilon. So, this dependent variable is F, that is resistance and here functional equation as you can then express as F will be equals to that dependent variables will be independent is a function of independent variables like mu, rho, V, d and epsilon. Now, next step is the functional equation in the form here F will be equal to C mu to the power A, rho to the power B, V to the power C, d to the power d and epsilon to the power E. As per that step I have described earlier, accordingly you have to express this. After that you have to express each of the quantities in the equation in fundamental dimensions. Like this, F will be equal to C into mu to the power A, rho to the power B, V to the power C, d to the power d and epsilon to the power E. Now, in this case what will be the dimension of F? That earlier I told that you have to remember some dimensions of that quantity. So, that will be equal to ml t to the power minus 2 for F, and C will not have any dimensions here. ml inverse and T inverse, it will be the dimension of viscosity, and dimension of density is ml to the power minus 3, and dimension of V is L T to the power minus 1, and dimension of D is L, and dimension of epsilon is L. So, based on that dimensional homogeneity concept, the simultaneous equations involving A, B, C, D, E can be represented as, if you equalize the dimension on both sides of this equation number 3 here in the slide, you can write this what will be the dimensions of M first. In the left hand side, dimension of power of this dimension M is 1, whereas the power of this dimension M on the right hand side of this equation number 3 is A and B. So, it will be 1 is equal to A plus B. Similarly, dimensions if you consider for L length, then it will be 1 is equal to minus A minus 3B plus C plus D plus C as given in equation number 5 here. Similarly, for time the dimensions can be compared, and you can make this equation as minus 2 equals to minus A minus C, that is given in equation number 6. After that you have to solve these 3 equations, what is that 4, 5 and 6 like this. Here first you have to express that 7 this equation number 4 as B is equal to 1 minus A, and then equation 6 is equal to 2 minus A, and equation 5 can be represented as D in terms of 2 minus A minus E. So, in this case you have to select that B, C, D, that will be represented by some other exponents as per that equation. Now, after that formation of the dimensionless groups like this, if you substitute that value of B, C and D, all are that in terms of A and E or like this. So, you just substitute that value of that B, C, D there in equation number earlier that in equation number here 2, then you will see that and segregating those things, and you can represent this one as the left hand side and this one will be as right hand side here. So, in this case you will see that this one is one group and this one is one group, where these groups are actually made as dimensional. You just check it that rho b d by mu, it is a dimensionless, even epsilon by d is also dimensionless, even f by rho v square by d square, this is also dimensionless. So, these three dimensionless groups are formed, and these dimensionless groups are interrelated like this. Any, suppose if you are considering that dependent variables is f there, flow resistance though. So, the dimensionless groups that is made by that, or in terms of that flow resistance, that is dependent variables, that will be, that these groups will be the dependent dimensionless groups, whereas independent dimensionless groups are here this one and this one. So, in this case we can make this functionality as like f by rho b d square by d square, this is this dimensionless groups as a function of this dimensionless groups of right hand side here. Now, this is called one equation or functionality which are expressed in terms of some dimensionless groups. Okay. So, this is called rational equation, where there will be no dimensions on both sides of this equation, whereas all those variables are taking part in this equations, and the effect all those variables on that dependent variables will be assessed by this equation there. Now, what should be that functionality, exact functionality, exact equation that you can assess by that regression analysis or fitting that equation with the experimental data. In that way you can form an equation. So, your job is to make its dimensional analysis and make it the rational equation by that dimensional analysis. Now, this is very important here, but one important things you have to remember here, that how many dimensionless groups can be made based on your number of variables. If you have 5 variables, you can make 5 minus 3, that will be equal to 2 dimensionless groups. If you have 6 variables total, dependent and independent all total, if you have 6 variables, and then you can make 6 minus 3 total, that 3 dimensionless groups. The basic rule is that this, if you have n number of variables, then you can make the dimensionless groups, or the dimensionless groups will be formed as n minus j. What is j? J is the number of fundamental dimensions. Generally, number of fundamental dimensions are 3. So, here the number of fundamental dimensions is 3, whereas the total variables is, if it is n, then it will be is equal to n minus j number of groups will be formed. Here in this example, you see how many variables are there. Here mu is 1, rho 2, v 3, d here 4, epsilon 5 and f 6, total 6 number of variables, whereas we know that fundamental dimensions, number of fundamental dimensions is 3. So, how many groups will be formed? That will be 6 minus 3, that is 3 number of dimensionless groups will be formed. So, you will see that after dimensional analysis by this Rayleigh method, you got these 3 groups, here this one and this one. These 3 groups you got, those are dimensionless. So, this is the basic theory to get how many number of dimensionless groups based on your number of variables. Now, we will discuss about that Buckingham's pi method. This is another method to analyze this dimensions, that is dimensionally making that dimensional analysis by this Buckingham method. in this case also you can make that rational equation where all the groups will not have any dimension there. And in this case what you have to do, according to that theory, the functional relationship among variables like x1, x2 and xn can be expressed as that function of x1, x2 and xn, that will be equals to 0. And here n will be equal to number of variables, and if j is the number of fundamental dimensions such as meter, that is length as L and mass as m and time as t, then MLT, these are that fundamental dimensions, then number of dimensionless groups can be formed n minus j, that already I told here during the analysis of dimension by Buckingham method. Here also same number of dimensionless groups will you will get. Now, the dimensionless groups are expressed as here according to this Buckingham pi theorem, that pi I will be equal to x1 to the power a I and x2 to the power b I and xj to the power j I, and that into xj plus 1. Here x1, x2, xj are called repeating variables and xj plus 1 are called that non-repeating variables. So, some variables will be repeating again and again, it will come for that analysis of dimensionless groups here, like pi I. Here pi I means dimensionless groups, here maybe n number of dimensionless groups will be formed. Here 3, here all these 3 dimensionless groups repeat is coming, then x1a, x2, x dot dot xj and then xj plus 1 accordingly it will come. Okay, we will see here number of repeating variables is equal to number of fundamental dimensions. You have to consider that repeating variables will be number of fundamental dimensions, that will be 3. So, here x1, x2 and dot dot xj, these are called repeating variables, this should be that only 3, whereas xj plus 1 will be remaining other variables there, and generally j will be equal to 3 here. And functional relation among dimensionless group is here, this will be then if you get that dimensionless groups as phi I, then it will be represented as function of phi 1, phi 2 and dot 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 phi I, that will be equals to 0. Here this functionality in terms of what is that in terms of that phi, that is dimensionless groups. Here also we can analyze this dimension by Buckingham method stepwise, like step 1 you have to first identify the relevant variables and function, and then write down the dimensions, and then establishment of the number of independent dimensions and non-dimensional groups, and then at step 4 choose that dimensionally independent repeating variables. Generally that repeating variables will be that first repeating variables will be fluid properties, and the second is flow characteristics, and the third will be geometric variables. So, in that way you have to select this that repeating variables. So, you cannot select that repeating variables like fluid property at 3 times like that. No, you have to take in such a way that from the each that characteristics like fluid property, flow characteristics and geometric characteristics, you have to take one that dimensions from each of these variables. Then step 5, you have to create the phi s, that is dimensionless groups, by non-dimensionalizing the remaining variables and by solving the coefficient. And then you have to set the non-dimensional relationship and then rearrange for convenience, you can say. In this case you are free to replace any of the phi s group by a power of that phi or by a product with the other phi s, provided retaining the same number of independent dimensionless groups. Like we will do that example again based on this Buckingham pi theorem. Let us consider a frictional resistance again, that F, when a liquid is flowing through a pipe that depends on the viscosity, density of the fluid, velocity of the flow, diameter of the pipe and pipe surface roughness. In this case also you just derive that rational equation based on this Buckingham pi theorem in terms of dimensionless groups. Now, first of all you have to consider as a step 1 that what will be the relevant variables and the function. So, relevant variables are that is flow resistance, viscosity, density, velocity of the flow, diameter of the pipe and pipe surface roughness. So, out of which you can say that some will be dependent, some will be independent, but all together all the variables to be noted down and you have to make the functionality like this here, function of f, mu, rho, v, d, epsilon, that will be equals to 0. But here the difference from that Rayleigh method is that here this f certain dependent variables will be a function of independent variables, it is not make here general that maybe that mu will be a function of some, in this case directly just one functions to be formed like this. And then you have to note down what could be the dimensions of each variables here. What is the dimension of f, what is the dimension of mu, what is the dimension of rho, what is the dimension of v and what is the dimension of d and then epsilon also. So, in this way note down all the dimensions for all variables. Now, in this case what will be the relevant variables, number of relevant variables is 6, that is n is equal to 6. Number of independent dimensions are generally 3, that is j, that is m, l and t, and number of non-dimensional groups will be then made based on the principle of n minus j, that will be equal to 3, that is 6 minus 3 is equal to 3. Then next step is that you have to choose 3 dimensionally independent repeating variables. That repeating variables you have to take one from fluid property like here density, one from flow characteristics like velocity and one from geometric characteristics like diameter of the pipe. So, these 3 repeating variables will be chosen here for the analysis. So, this is very important. You cannot, I told that you cannot repeatedly three that repeating variables will be taken as rho, rho, rho or rho v again rho, you cannot do that. Separately you have to take these repeating variables, one from fluid property, one from flow characteristics, one from geometric characteristics. Okay. And then you have to create that dimensionless groups. What is the principle? That first dimensionless, since you are going to form n minus j, that is 6 minus 3 dimensionless groups here, that will be phi I will be equal to what is that phi 1, phi 2 and what is that phi 3. So, phi 1 what is that will be equal to rho, v and d, these are the repeating variables, and non-repeating variables here, one is f, other non-repeating variables mu and epsilon there. So, you can make like this with that non-repeating variable, with that repeating variables you can make the functionality of functional dimensionless groups like this. Similarly, for second dimensionless groups you can again use that repeating variables of that rho, v and d and other that non-repeating variables here mu, and here phi 3 again with that non-repeating variables, with that repeating variables you have to make the equation like this. So, in this way you have to do that dimensionless groups here. After that what you have to do? You have to do that dimensionally consistency just by equating that equation here, in this case like phi 1 is equal to this from that equation here. In this case phi 1, if you consider that phi 1 is equal to rho to the power a 1, v to the power b 1 and d to the power c 1 and into f, then if you consider that dimensions of all these variables in the left hand side and right hand side. In the left hand side, since phi 1 it will be dimensionless groups, then no dimensions will be there. We can represent it as m to the power 0, l to the power 0 and t to the power 0. What does it mean? There will be no dimensions here. Similarly, for right hand side part, if you note it down that what is the dimension of rho, then it will be ml to the power minus 3 and there is a power a1. So, these dimensions to the power a1. Similarly, for v, similarly for d, similarly for f also you have to write down like this. After that, just you equalize these dimensions power of these dimensions from this left hand side to the right hand side, then you can make an equation like this with that exponent here. Here in this case, if you are considering first m, then what is the dimension of what is the power of m here? 0, and in the right hand side what are the power of this m here? Here one is a1 and here is 1 here. So, here simply a1 plus 1, that will be equals to 0. Similarly, for L, if you consider that power on both sides, then it will be as 0 will be equals to minus 3 a1 plus b1 plus c1 plus 1. Similarly, for that t, if you equalize that exponent of this left hand side and right hand side, then you can have this equation of minus b1 minus 2, that will be equals to 0. Now, solve these 3 equations, you will see that the solution of these equations will give you that a1 value will be equals to minus 1, b1 will be equal to minus 2 and c1 will be equals to minus 2. So, in this case, if you substitute that a1, b1 and c1 in this equation and rearrange this, you will see that this pi 1 will be as f by rho v square d square. You just check it and substitute the all dimensions here, you will see this phi 1 will not have any dimensions. So, this is dimensionless groups simply. Now, this pi 1 is simply f by rho v square d square. Similarly, consider that phi 2, again that you have to that equalize the power of all dimensions from its left hand side and right hand side after substitution of dimensions of each variables there. You will see these 3 equations will be obtained, and after solving these 3 equations, you will see that the value of a2 will be coming as minus 1, b2 will be coming as minus 1, again c2 will be as minus 1. And if you substitute this a2, b2 and c2 value here in this equation, you will see that after rearrangement this phi 2 will be as mu by rho vd. Again you just check it that this groups will not have any dimension, that is why this pi 2 will be as a dimensionless groups. Similarly, for phi 3, you will see that if you again substitute the dimensions of all variables here and compare the power of these dimensions on left hand side and right hand side, you can have these 3 equations here, and after solution of these 3 equations, you will see that the value of a3 will be 0, b3 will be equals to 0 and c3 will be equals to minus 1. And again if you substitute this value of a3, b3 and c3 in this equation phi 3, you will see that it will be as epsilon by d, because here a3 equals to 0 means here rho to the power 0 it will be 1 and v3 v to the power b3 is 0. So, it will be simply 1. So, only remaining are d to the power c3 is minus 1 and epsilon. So, epsilon there is nothing there. So, epsilon is there already. So, epsilon by that d will be there. So, this is simply that dimensionless groups. So, phi 3 another dimensionless groups. So, we are getting 3 dimensionless groups in terms of all the process variables. Now, you have to make that that functionality based on this formed or developed, or you can say that that dimensionless groups that is formed based on that dimensional analysis. So, that will be equal to function of phi 1, phi 2 and phi 3, that will be equals to 0. And after that you can make any relationship like phi 1 is a function of phi 2 and phi 3, or you can say that phi 2 is a function of phi 1 and phi 3, or you can say phi 3 is a function of phi 1 and phi 2. So, in that way you can form, but since in your problem it is seen that flow resistance is depending on the other variables, that is f is depending on the other variables. In that case you have to make the functionality like this, what are the groups is coming based on that f, that you have to make it as dependent variables, dependent dimensionless groups, and this will be made in terms of other dimensionless groups. So, in this way you have to make the rational equation, and then you have to rearrange it like this, and then you have to make this as like you can say that if suppose this group 1 or phi 1. So, you can phi 1 as a suppose some value of lambda into phi 2 phi 2 to the power phi 1 as a function like this, phi 1, this is phi 1 and this is phi 2 and this is phi 3. So, in this case this phi 1 will be a some functions like this a into you can say phi 2 some power b and plus here also you can say phi 3, or you can make like this type of function like this phi 1 will be equal to that lambda into that phi 1 to the power m and phi 2 to the power n, like this type of functionality also you can make. So, either way that depends on your experimental data, how this that flow resistance will be changing with respect to variables. So, if you have that different data based on changing of independent variables and its result of that dependent variables, and after that you have to fit this equation, either of this equation if you feed this with that experimental data, then you can form or you can have this that value of m, n and lambda value there, or here a, b and some c value there. So, in this way you can find out that coefficient, and if you know that coefficient there will be a final form of rational equation, and then you have to also check which equations will be suitable and which will be giving the least error of that fitting of that experimental data with this equation. That is further step, but up to this you have to know how you can make that rational equation as a function of dimensionless groups, and this is called dimensional analysis. So, there are two methods that I have discussed here, one is Rayleigh method, another is Buckingham pi method. Which one will be easier, you have to follow. So, any problem you can solve by this. Okay. So, here another example here, flow resistance of a sphere. In this case again that Buckingham pi method you can use here, like the drag d of a sphere is influenced by sphere diameter d, flow velocity u, fluid density rho and fluid viscosity. What is that? Whenever any sphere is suppose fixed in a certain position and some fluid velocity is flowing over that spherical particle or sphere, you will see there will be some drag or resistance, or you can say that frictional force will be acting on that surface of the sphere with that fluid. So, that drag force actually of that sphere is depending on the diameter of that sphere, and also how or what is the velocity of that fluid, and also density of the fluid, and also viscosity of the fluid. So, this drag force actually depending on this diameter of the sphere, velocity of the fluid, physical properties like density and the viscosity of the fluid. Now, in this case how many variables are there? We can say that drag here, spherical diameter, flow velocity, density and viscosity, total 5. Now, how many dimensionless groups can be formed by either of this method? Very simple, 5 minus 3. 5 is the number of variables, and you know that 3 is here number of fundamental dimensions. So, here 5 minus 3, that is 2 dimensionless groups you can make by this. So, if you follow that Buckingham pi method with this you know that variables, you know that rho v d as repeating variables, you can make like this, pi 1 will be equal to this, and equalizing that power of the dimensions on both sides of this equation, and making this equation based on which you can solve, and you can get that, you know, power of that as minus 1 minus 1 minus 1, and then you can form that pi 1 will be equals to this. Similarly, other dimensionless groups, again that repeating variables will be there, and with non repeating variables of other non repeating variables here mu. So, accordingly you can solve these equations just by equalizing the power of those dimensions on both sides of the equation. Then you can get the solution of power of x, y and z like this, and then substitution of those values you can get this value of pi 2. So, here pi 2 is a one dimensionless groups, here pi 1 is also dimensionless groups. You just check it that there will be no dimensions on these groups, and then you can make that rational equation just by a functionality like that pi 1 will be equal to function of pi 2. Now, how it will be related, that is different issue, that depends on the process variables. Now, generally this, suppose here pi 1 that will be is equal to some you know that m into pi 2 to the power n, like this. In this way also it will be varied. Now, you have to find out what will be the value of m and what will be the value of n from your experimental data, just by fitting these things with experimental data. You have to find out what will be the experimental data of phi 1 after calculation, and then phi 2, because phi 1 you can calculate simply d by rho u square d square, all these things known to you, because d is known to you, rho is density is known to you, velocity you are you know giving, that is also known to you, d is also known to you, just then what will be the phi 1. Similarly, if you change that variables, accordingly pi 1 also will change. Similarly, pi 2 also will be changing accordingly if you change that viscosity, density, diameter of the column, velocity of the. So, accordingly you will see how that this pi 1 will be changing based on that phi 2. So, then you will get one you know that equations based on this you know phi 1 as a function of phi 2. Then you feed that experimental data of phi 1 and phi 2, and then find it out by least square method. We will be actually discussing how to find out that all those components later on. Okay, how to find out this exponent just by fitting with the experimental data, that will be given in separate lecture later on also. Okay, so this way. So, how to make the rational equation based on this dimension analysis by Buckingham pi theorem or Rayleigh method, you just I think learned here, and you can practice also with some examples given here itself. Now, for chemical engineering process you know analysis like this, we you know form some dimensionless you know groups. You will see some dimensionless groups will be you know some significant groups, that is actually very important for the analysis of process performance there. So, some dimensionless groups are given here in the slides here, like Reynolds number that we got, even Froude number, Allen number, Weber number, Mach number, all those things and relative their significance it is given here in the slides. Even in the next slides also it is given some significant groups and their respective you know that significance there, and how they are defined, it is given there, their name, group, and so you have to you know remember this you know dimensionless groups. You check this all this you know group whether they are dimensionally you know consistent or not, or you can say that whether these groups are having any dimensions or not. You will see that no groups will have any dimensions here. So, all those dimensions will be you know using for certain process analysis in chemical engineering. So, in future also if you do some other courses like heat transfer, mass transfer, even transport phenomena, fluid mechanics, then there you will see all those processes there, you will see certain dimensionless groups you will be having for their process analysis. Like this here for flow generally Reynolds number, Froude number, Euler number, even Weber number, even Mach number, all those groups are actually related to the process where flow of course will be there, or fluid mechanics related any process there, these groups will you will get. Whereas you know that for heat transfer operations you will see that Prandtl number is one dimensionless groups, Nusselt number is one dimensionless groups, even Grashoop number, this is the dimensionless groups. These three groups are very important in heat transfer operations, where the chemical engineering process are related to the heat. That we will discuss that different process. I think we have given in the previous lecture that different processes related to the thermochemical processes, even mechanical processes, they are all those processes, those processes are related to the heat energy. There also you will see that these dimensionless groups like Prandtl number, Nusselt number, Grashoop number are very important. Even for mass transfer operations, suppose if you are actually transferring one phases to another phases, like absorption of carbon dioxide gas to the liquid, their transfer of carbon dioxide gas to the liquid. So, in this is called mass transfer operations, or diffusion. You will see that diffusion process. If you suppose spread some perfume, you will see that perfume will be diffused throughout the room. So, they are the transferring of molecules from one position to the another position based on that that concentration gradient. So, this is called diffusion process. There also some dimensionless groups are very important, like Schmidt number, that is related to that molecular diffusion, even Sherwood number, that is mass transfer operation, like that gaseous molecule will be transferred from gaseous phase to the liquid phase. So, in this way these dimensionless groups are very important. I suggest you to remember these dimensionless groups throughout your life. I can say that as a chemical engineer, if you are doing the course of chemical engineering, or you are studying that chemical engineering course, that you have to remember these groups there. So, thank you for your concentration of this lecture. I think you understood that how to do the dimensional analysis, and how to make the rational equation based on the dimensions, and what are the different systems of units that you understood. So, next lecture we will discuss something more about that physical and chemical properties of the material, which are very important in chemical engineering processes. So, thank you for your attention.